Good morning, good afternoon, good evening, wherever you are on the planet today. Hope you're all well and safe. I've got some great slides to share with you and some great information about products that are launching today and available today. So with much ado, let's move on. So all of you are on your Redis journey. You often use Redis when you're first starting out as a cache. And so what I'm going to talk about is not only the growth of how you use Redis, but how Redis has also grown from Redis 3, 4, 5, and 6 over the last few years. And so we're just here to acknowledge that growth happens, and how you think about Redis and how you think about using it is going to change over time. So let's look at some criteria to use Redis as a database, not just as a cache. And here are just 4 things we're going to talk about this morning: authentication, encryption, global availability, and consistency. These are all key aspects of characteristics that you'd expect for a database. And we're going to talk about all these things in context of Redis. Now, I'm talking about Redis as a database. And I think there is still an audience out there, and there's a couple of people still to convince. Charity I've known for years through other companies and other events in community, and she's has a very vocal opinion, and I think her opinion is shared by many others. And part of what we're trying to do is to show you how Redis has evolved and changed over time. And perhaps it's now time to think of Redis as a database. So let's talk about the first thing we want to announce today. So Salvatore has released open source Redis. What we want to announce today is the availability of not only just Redis open source, but Redis Enterprise. So you can go download it, you can use it, you can give us our feedback, and you can tell us all the great things that you love in it and all the things that you want next. Let's have a sort of quick look at what those major features are. In open source, Salvatore's talked about access control lists. And so this is a very important step on the journey to make Redis a robust and reliable database. There's many other things that also changed, improved in open source 6. There's improved elections, there's a new threaded IO, and as you saw, there's a demonstration just now for the REST 3 protocol. These are great features that are being added into the open source project to extend its capability. Layered on top of that is Redis Enterprise. And so we've been actively working to add in those additional functionalities that enterprises are craving for. And so we've taken access control lists and we're adding a layer above that to do role-based access control. And so this just allows simplified administration at scale. We've also been extending our active technology to incorporate hyperlog and streams. And so we're going to talk about a couple of these things as we go through these slides. So let's first talk about why does access control lists matter? Well, the key thing that's been introduced is the ability to specify for a given set of keys what operations can be performed. So in this first example you see here, we have Alice. There's a regex expression for the keys that they can match, tilde, cache, colon, star, and then the operation that can perform. So this allows for a strict separation of concerns between what the application or a service might need to access and what commands the administrator will need to access in order to maintain the Redis cluster. So you can now separate these groups apart. What this means is that you've got a far reduced attack surface. You no longer have a single user that you're authenticating against. You can now set up all the different users and roles as required to meet any compliance or regulatory needs that you have. My favorite part of ACLs is, and I've done this plenty of times, is remove the ability to run flush DB, i.e. clear out the entire cache. So, automatically removing myself the privilege to run that command is saving me a lot of fat fingering. So if that's ACLs, how do they look and how do they compare to role-based access control? So you see on the left here, we can set up each individual with particular permissions on keys and commands. And so that is really great in a development and test environment. It allows a very simple way to administer and set up all of those rules. But when you start to get at scale at a larger enterprise, role-based access control allows you to define the role once with those permissions and then assign users to that role. That means that you can change the role definition and all users now conform to that, rather than having to go through user by user by user. So that greatly reduces the administration burden in day two operations. So we think it's a really great set of features, but it's just the first sort of step on the path for the Redis 6 family. What are we working on next? Well, now that we've got role-based access control, many people will want to configure them through external identity providers, so Active Directory or LDAP. So the next step is to be able to configure those roles not just within a Redis Enterprise cluster, but from outside the Redis Enterprise cluster. Again, this simplifies the administration burden. We're adding TLS 1.3 support, so we're getting the latest ciphers, the latest version. We're also adding mutual TLS authentication, so you only need the certificate chain only. And then we're extending active support to support search. And if you're not familiar with Redis Search, this is an extension to core Redis that allows you to do full text search, doing stemming, stop words, and all the other great fuzzy matching and text searching that you can do. So these are sort of some really great things that we're working towards in Redis 6. So what are the next steps? You download the software. You can use it on the cloud right now and go for a free tier service just to go try it out. There's a couple of great sessions in the conference today and tomorrow. And so there's a security best practices by one of our product managers. There's also a great talk by Apple about how they're using these features in Redis 6. So if you've got an interest in this area, I'd love for you to go and check those out. So that's the first thing I wanted to talk about today. What's the second thing? Well, encryption in use. So encryption in general is a very well-known thing that you want to do. But what about encryption when you're using the data? So let's first think about what is the state of encryption in Redis today, right? So you've got encryption at rest. You can use encrypted disks or encrypted volumes so that that data, when it's at rest, is stored in an encrypted way, which means that if that volume is compromised, then the data is not usable because you don't need the keys. Encryption in transit, well, we've got TLS support, so that means that the traffic going in and out of the cluster is all encrypted. But what about that data that's in use, that key value? And so the way that most people kind of start to think about encrypting the data in use is by encrypting it at the application. So we have a very simple example here where we are taking the value 33. We are going to encrypt that value with OpenSSL. We get this big, long gobbledygook string. And then in the Redis CLI, I can now set my key with that gobbledygook string. This is great. The application has encrypted the data. It's passed it to Redis to store it. And Redis is now storing that encrypted value. Well, the downside of doing application level encryption is that you can no longer perform certain database operations. So if you look at this next command, we'd now try to increment that value by 1. But that value is not a plain 33, it is a binary string. And so Redis return that it can't increment that value. So by doing application level encryption, it means that whilst your data is secure in use, you're not allowing the database to perform operations against some of that data. So what we're super excited to announce today is a combination of 3 pieces of technology. Secure Enclaves from Anjuna, plus Redis, plus secure Microsoft compute from Azure. So these technologies combined allow you to solve this problem in a very interesting and unique way. So let me kind of dive into that a little bit more. So Anjuna provides what they would describe as an enterprise enclave. Now, this is all based on the fundamental work that Intel, AMD, and ARM have been doing to introduce new instructions and new capabilities in their chipset to allow essentially a process space to be secure to a single process. So up at the top we see Redis. An enclave is created around it, so its network, storage, and memory are essentially private to that process. And what that means that from the outside of that enclave, everything looks encrypted, but to the inside of the enclave, that process sees that data in plain text as it would do it normally. So why is that important? Well, a couple of critical things. First, it means that data in memory is now protected. It's now encrypted. So if I do a core dump or a dump core of that process or do inspect the memory, all I see is encrypted data. I no longer see that plain text data. But it also means that because the process inside that enclave can see the unencrypted data, all of the database operations are still possible. I can now still do my increment on what the outside world thinks is an encrypted value, but on the inside is a plain value that those operations can now perform. And this is kind of critical because what this means is you don't have to change any of your application code in order to take advantage of the data now being encrypted in use. So how is this all done? Well, Anjuna are providing the technology to wrap this up. As I said, it's using the base capabilities of the CPU from AMD, Intel, and ARM. On top of that, you've got the operating system, the containers, and the virtualization. And the final part of the deployment is its availability in numerous cloud vendors. So in terms of the CPUs, every CPU shipped in 2021 is going to have this capability, and the cloud vendors are slowly rolling out this capability. And Microsoft Azure Secure Compute is one of the first ones out there. So we're super excited about that. What are the kind of next steps for in-memory encryption? Well, obviously try it. It's available as an open source image on the Azure Marketplace today. So go have a play with it. We're currently working on the validation to validate the technology with Redis Enterprise. And we're performing some initial performance benchmarks because, as we all know, encryption is not free. What we want to understand is the performance implication to various workloads and what that means. There is a talk in the conference that if you want to find out more, that's been presented by Redis Labs, Anjuna, and Intel. So lots of really great content. So that's the second thing. What's the third thing I want to talk about? So again, this is available today. We are announcing the availability of streams plus active-active. So what does that all mean? Streams, if you're unfamiliar with in Redis, have been available since Redis 5. They've been very, very popular since Redis 5 first came out. And essentially, they're log structured append-only data model. Now, Redis has had a traditional pub-sub mechanism for many, many years. But you would only get those messages delivered if your client was connected when the message was pushed. What streams do is they add the restartability. So it means that from reading a stream's perspective, you can reconnect at any point and start your window or a point in that stream where you want to carry on reading from. So this is great in terms of the reliability, but also the additional things that streams provide is consumer groups. So I can now subset this stream by processing by different clients and making this a very scalable solution that is very reliable because of the restartability. So that's streams. What about active-active? So active-active, again, is a technology that's been available in Redis Enterprise for many years. But what it is intended to do is provide geo-replication between Redis clusters across availability zones, data centers, or even geographical regions. And the mechanism behind how this works is CRDTs, or conflict-free replicated data types. So this allows Redis to have automatic ways to resolve conflicts when two different clusters have performed writes against the same key. Because the inherent nature of Redis with its data structures and the operations it can perform against those data structures, it means that there is many different strategies can be employed by data type and by operation. And this allows for a very sophisticated approach to how those conflicts can be resolved. The great thing from a developer's perspective is that you get very low latency on those local writes. So you get all the characteristics of Redis you'd expect. Those low latency writes are then propagated to the other clusters, and they will eventually coalesce to a single value. So what does it look like if we combine these two technologies together? Well, this is a bit sort of complicated to follow, but let me try and walk you through it. So we have two clients, client 1, client 2. These can be in two separate clusters that are linked together with active-active. So we see on step 1, an add to that stream takes place, and a read can occur, and you can see that value that's being added. If you now look at step 2 on client 2, reading that group means the entry is not visible because those changes have not been synchronized across the clusters. So we see at step 3, the synchronization is completed, and therefore the replication is completed. On client 1, we can acknowledge that we've processed that event, that entry, and if we now look at the stream again, it's empty. If we look at step 6, we can now see that on the second client, if I now do a read, because those changes have been synchronized, I can now see that value. And if we now go on to step 7, that after another synchronization has occurred, it means that that acknowledgement of that message by client 1 is now being synchronized. So when you go to read the group again, the entry is no longer visible. Right, so you've now created an application where you can process these streams in a globally distributed way, but ensuring that you're always getting a consistent view of those streams, irregardless of which cluster you are reading from. We think this is absolutely going to be awesome. So what are the next steps? Well, obviously, you can download and try it. There's a couple of great talks by Redis Labs, but there's also talk about by Uber about how they use this active-active with streams to solve many, many use cases in their environment. So that's the third awesome thing that we're announcing today. Now, the final thing I want to talk about, I am really excited about a project that's been going on for many years internally within Redis and Redis Labs, which is all about how to think about data consistency in Redis. So what we are, if we think about consistency in Redis today, is Redis is inherently an AP system, right? So it's going to choose availability over consistency because it's a distributed system, so it has to do partition tolerance. Now, with active-active, as we just talked about, you get strong but eventual consistency. So there may be some propagation delay between particular clusters between that data to be available. And strong eventual consistency solves many, many problems. But what we're excited to announce today is sometime early this summer, we're going to be open sourcing a new module to Redis called RedisRaft. And what this supports is strong consistency. And so this now opens up a whole new set of use cases where you're guaranteed the data consistency irregardless of where you're reading from within that cluster. We think this is going to be very, very exciting. So let me give you a little bit of context. So we're basing this on Raft. And Raft is a very popular consensus-based algorithm for replicating state across many machines. There's a bunch of implementations, and it's used widely by things like etcd, Console, MongoDB, a bunch of other database products. There are other consensus algorithms, like you may have heard of Paxos, and Paxos is another typical one that's used to solve this problem. So if that's Raft, what is Redis plus Raft? Well, what this gives us is the ability to offer strong consistency for a cluster of Redis servers. The RedisRaft module itself is responsible for things like leader elections, replication, persistence. And as we go on, we're adding more capabilities so that will allow for things like dynamic cluster membership, being able to manage the resources to support this consistency, as well as adding things like performance and tuning knobs so that you can optimize your deployment for your particular use case in the most effective way. What are the next steps? So when we open source this early in the summer, please download it and try it out. Give us your feedback. It's not ready for production, right? So we're still working on it. We're still validating it. And so please, please, please don't put this into production. We're doing a whole bunch of testing, and there's a great talk later today, but we're doing some initial Jepsen testing is complete. Obviously, we're finding issues, we're correcting those issues, we're retesting. And as the year progresses, we'll be extending the Jepsen testing to Redis Enterprise, so we'll make this not only available for open source users, but also for enterprise users. If you want to know more about the state of where we are in the development and the technology behind it and how we've been doing the testing, there's a great talk at the conference by Yossi, who's one of our chief architects, and Carl Kinsbury, who's the man behind all the Jepsen testing. So great things. So super excited about that. So just to wrap up and conclude, it's time to stop thinking of Redis as just as a cache, right? Redis is growing up just in the same way that the use cases you have built using Redis and how Redis has changed with additional data structures and access control lists is changing and growing as well. Growth happens, and Redis Enterprise now gives you a way to get some of this extended functionality in order to extend these sort of use cases. So that's all I've got for you this morning. There's a bunch of awesome, great things that I would love for you to try out, give us feedback, and I hope the conference gives you a lot of great information to continue your journey with Redis.